This is lesson 16 on the organic chemistry series and the last lesson about names, right? And it's talking about common names, right? We've already gone through all of the system of what we call IUPAC, the International Union of Pure and Applied Chemistry nomenclature, right? So those are really the kind of the official, the worldwide official names for things, right? But you still run into a whole bunch of common names, which they've been around for a long time. They may have been in place before the IUPAC system was put in place, and so a lot of people just continue to refer to them by their older, more common names, right? And because you see it, right, you should be aware of it. So that's why I'm going to go over things, right? So I've got a list of common things, common names for things that you're going to see, right? And we'll go through them one by one, right? First is the prefix form, right? Form is like it's equivalent to meth, right? It refers to one carbon, right? So what kind of things do you see? Well, you see things like most people know of formaldehyde, right? Formaldehyde was commonly used to preserve things, biological specimens in, right? So you can kind of break down knowing that form refers to one carbon, and we know what an aldehyde is now, right? It has one double bonded oxygen. So if I draw one carbon with one double bonded oxygen, right, that'll make an aldehyde, and then hydrogens to complete the remaining 4 bonds to the carbon, we now have formaldehyde, right? Another one that sometimes is mentioned, right, is antivenom, right, which is formic acid, right? It can make you go blind, right? It's also the metabolic product of drinking wood alcohol or methanol, which will also make you go blind. It's not actually the methanol that makes you go blind, it's the metabolic product of metabolizing methanol, formic acid, that makes you go blind, right? Again, one carbon, and we know what ic acid refers to, right? So let's draw a carboxylic acid with only one carbon. There it is, right? That's formic acid, right? So form is really just another way of referring to meth, right? This would be methanoic acid. The previous aldehyde, formaldehyde, would be methanal, right? In IUPAC nomenclature, right? So that's form, right? So we can get rid of that, right? Acid, right? Acid, like form, refers to 2 carbons, right? So things that we know already, like acetic acid, right? In vinegar, right? Well, acetic acid, right, would just be 2 carbons with a carboxylic acid. So there's 1 and there's 2, right? And there's acetic acid, 2 carbons, carboxylic acid, right? And of course, what happens when we deprotonate a carboxylic acid? Well, we replace the ic acid with 8, right? And we get, oh, acetate. We know that one too, right? Now, there's a weird one, acetone, right? It used to be very common to use acetone as nail polish remover. You can still get it as a solvent from hardware stores. The only problem is if I draw 2 carbons bonded to each other, and we know that -one is the suffix for a ketone, which means I need to put a double bonded oxygen on there. It doesn't really actually matter whether I put the double bonded oxygen onto this carbon or onto this carbon. It's going to be on the end of a chain. In which case, if it's on the end of a chain, it's not really a ketone, is it? It's an aldehyde. So it's actually kind of impossible to have a ketone with only 2 carbons. With only 2 carbons, no matter where you put the double bonded oxygen, you get an aldehyde, right? So the only way we can get a ketone out of it is to put a 3rd carbon in, right? And so we're saying, oh, well, you know, it's a ketone where if we're calling this our ketone and this is the other side chain, I guess, that comes off the side, right? We actually end up with 3 carbons in it, which I know acid is supposed to be 2. But like I said, you can't have a 2-carbon ketone, so acetone actually refers to what would otherwise be known as propanone, because it has 3 carbons in it. Okay. So that takes care of form and acid, right? It's like meth and F. Now, isopropyl, sec-butyl, isobutyl, and tert-butyl are actually common names for our complex branches. So remember when I had the big long carbon chain and I put a branch within a branch. So let's say that I go up here, right? If I put a 2 carbon branch like this, 1, 2, and then I put a methyl group coming off of that, it would be a 1-methyl ethyl, right? So this would be a 1-methyl ethyl group, where there's my ethyl group, and then there's my methyl group coming off the ethyl group, right? Well, the way isopropyl works is it says, okay, what if I looked at this instead like this is just a 1, 2, 3 carbon branch, right? So I'm not looking at where it's attached, I'm just looking at there's 3 carbons in total, right? Coming off of the main chain. So we're going to call it a propyl because it's got 3 carbons, but since the carbons are arranged such that it's balanced or equal on both sides, that's what iso means. So since it's got 1 carbon on one side of where it's attached and another carbon on the other side of where it's attached, it's attached in the middle, right? So it's balanced on both sides. We call it isopropyl, right? Because propyl would mean that it's attached. Propyl would just mean that it's attached at the end. You have 1, 2, 3 carbons attached right at the end. That would be a propyl chain, right? Well, if we just take it and then attach it at the middle carbon instead, right? They call it isopropyl. Right? So isopropyl is your 1-methyl ethyl complex branch, right? Now we can do the same thing with butyl, right? If I were to just take, why don't I go 1, 2, 3, 4. I have a 1, 2, 3, 4 carbon branch. That would be a butyl branch, right? But what if I take the 4 carbons and I attach them differently, right? So instead, right, I take 1 carbon, 2, 3, 4. So I have 4 carbons total, right? Well, normally what we would do is we would find the longest branch that's attached. So we'd call that a 1, 2, 3. That would be a propyl, and this would be a 1 carbon methyl group, right? So we would call this a 1-methyl propyl complex branch. So that's the one that we already dealt with in the complex branches. Well, instead, again, the common name treats this like it's a butyl branch with 1, 2, 3, 4. Now, it's not attached in a balanced way. It has 2 carbons on one side and only 1 on the other. So we wouldn't call this isobutyl, right? Instead, because it's attached to the 2nd carbon of the butyl chain, right, they call it sec-butyl because it's attached to the 2nd carbon, right? Now, when we have 4 carbons, right, we can arrange 4 carbons in 3 different ways, right? If instead of attaching to the 2nd carbon, what if I actually now make multiple branches coming out there, right? So I do that, right, and then I do that and that, right? I still have 4 carbons, right? If I were to name this as a complex branch using the IUPAC method, I'd say that's carbon 1, that's carbon 2, that's carbon 3, and then I have a 1 carbon branch coming off of it. So what would that be? Well, it's off the 2nd carbon of the so that would be 2-methyl propyl. So that's what it's normally called, right? But this one is attached in a balanced way, right? It goes up to the 1st carbon, then it attaches the 2nd carbon, and then coming off at the end of that, right, is 1 carbon on one side, 1 carbon on the other, right? So since it's completely balanced on either side, right, we, like isopropyl, we call it isobutyl, right? The difference is this one now goes up 1 carbon, and then before branching off like isopropyl, it goes up a 2nd carbon, then it branches off like isopropyl, right? So now we have a total of 4 carbons there. 1, 2, 3, 4. So we call it isobutyl, right? And then the last way that we can attach 4 carbons, right, is what if I go up 1 carbon and then I branch it off 3 times, all from the same carbon, right? Well, the way we named that originally is we'd say, okay, that's carbon 1, that's carbon 2, so that's an ethyl branch. and now I have one methyl branch coming off of it and a second methyl branch coming off of it. So I called it 1,1-dimethyl ethyl. That was the IUPAC name for the complex branch, right? But what we call this is that we, as a butyl branch, we say, okay, there's 4 carbons here, right? 1, 2, 3, 4 total. So we're going to call it butyl because it's got 4 carbons, right? And there are 3 carbons coming off of the initial one that's attached to the branch. And so if you think of it as primary, secondary, and tertiary, right? Tertiary is third, right? Or 3, right? Since we have 3 branches coming off of the original branch, they call it tert-butyl for tertiary butyl, right? So 1,1-dimethyl ethyl can also be called tert-butyl. Right, so these are 4 common names, right, for complex branches that we've already addressed in previous lesson. Right? So that's how we deal with the common names of complex branches. All right, now we get into some common names for molecules that we would already know, right? Ethylene, right? That's ethylene, right? Now that's 2 carbons, 1, 2, right? With a double bond, so we would call it eth, and then the suffix would be ene. So normally we call it ethene under IUPAC nomenclature. A common name though is ethylene, right? So they put the YL, right? Like it's an ethyl branch, right? And then the ene for alkene, right? Again, I don't know why they make things weird like this. Acetylene actually has a triple bond, right? So this has an ene in it, right? But it's not actually an alkene, it's actually an alkyne. And 2 carbons would be eth, and then with a triple bond we'd use the suffix "-ine. So the IUPAC name is actually ethine, but the common name is acetylene, right? At least they got the prefix right, it's 2 carbons, as opposed with acetone, which has 3 carbons, right? 2 carbons, acet, right? And then acetylene is actually an alkyne. Right? Alkyl halides, that arises when we know that halides actually have a lower priority than alkanes, so we're supposed to name it as a haloalkane, meaning the halogen is the branch and the alkane is the main chain. Well, if we turn that priority around and name it with the incorrect priority, we would be naming the alkane as a branch and the halogen as the main chain. So let's just say, for example, I take a 2-carbon chain and I attach a chlorine to it, right? Normally we would call this chloroethane, because the alkane, the ethane gets the priority, it's the main chain, and we have a chloro branch coming off of it, right? Well, what alkyl halides do is they reverse this priority, and instead they name the ethyl group as branch, and the chloride, right, as the main chain. So ethyl chloride treats the chlorine like it's the priority of the main chain. So you have this chloride with an ethyl group on it, right? So these 2 things mean the same thing, right? So that takes care of those. And the last thing for common names is simple ethers, right? We learned that ethers is when you have an O with some carbon chain coming off of it, right? And it's attached to some other main chain, like this, right? And we pick the longer of the 2 chains, right? So this is 1, 2, 3, 4, 5, 6, right? So that would be hexane. And the alkane gets the priority, right? And then the ether group is named as a branch. And that's 1, 2, 3. So it'd be propoxy. That would be prop for 3 carbons, oxy for the oxygen. So you get propoxy hexane, right? Well, when we name simple ethers, right, a common thing that you might see is actually that rather it just calls the molecule an ether, and then referring that there's 2 carbon chains on it, right? And it just puts both carbon chains as prefixes, right? You can name it again alphabetically, so PH, right? So propyl is P. H hexyl. So you go hexyl first, you know, hexyl propyl ether, right? So they name both carbon chains as prefixes, and then there isn't really even a main chain unless you just want to consider the oxygen to be the main chain, the ether. And they just name the chains on either side of the oxygen, hexyl propyl ether, right? And the reason I say simple ethers, it's simple ethers where you have an oxygen and you just have two straight chains that come off of it, because generally it's only when they're attached at the very end of the chain, right, and the chains are straight, that they name it this way. Otherwise they go back to the IUPAC naming, right? One of the most common that you see though is diethyl ether, right? It's a very commonly used solvent, and you often see it just called diethyl ether. So you would just draw the oxygen, and it's two ethyl groups. So there it is. It's diethyl, ethyl ether, right? So those are some of the simple names that you see for things that are not technically the IUPAC nomenclature, right? But they're common enough that you may see them around and you should know what they mean.